Hi everyone, welcome back to the SPARQ Observatory. This is Steve Smith and we're going to continue our journey in astrophotography processing. This video is going to be about histograms and using the histogram transformation tool just for our master Lumen image in PixInsight. I'll have another video for histogram transformation for our color master, our RGB master, later on in the process. So this video, histograms and histogram transformation. So a histogram is a two-dimensional graph. It measures intensity versus the number of pixels. So your camera chip will have a number of photosites. Those get translated into pixels on your computer screen in PixInsight or Photoshop or whatever you're using. And each pixel has a certain level of intensity, a certain level of brightness. So again, we're not dealing with color so much as we are absolute black to absolute white, although we do have histograms for color, and we'll talk about that in just a minute. But essentially, we're just mapping intensity on the x-axis versus number of pixels on the y-axis. Each of these does have limits, though. That's why I put a little cap at the end of the x and y axis there. The limit for the number of pixels is the number of pixels that you have on the camera chip, the number of photosites. And so when you download an image to your computer, there's only going to be so many pixels there. And for our SB camera that we have a little under 6,300,000 pixels that get used for a single image. So that is the limit. We can't go above that. And so the intensity, on the other hand, the x-axis, also has a limit, and that limit is 65,535. Now that sounds like a bit of an arbitrary number, black being absolute 0 and absolute white being 65,535, and then you can think of shades of gray as being in between those two numbers. Where does that 65,535 number come from? Well, we have a 16-bit camera, and that 16-bit camera, that number 16, is what gives us the 65,535 gradations of intensity. And the way that you calculate that is you just take the 16-bit and you raise that. You take 2 and raise that to the 16th power. And if you do that, you'll come up with 65,536, not 535. And the reason that the limit is 65,535 is we're actually measuring the intensity starting at 0 rather than 1. And that's why those two numbers are 1 apart from one another. So again, absolute black, absolutely no light, no photons hitting a particular pixel, that's 0. The full, what we call the full well capacity, and I won't get into that right now, that's a CCD chip kind of technology issue. You get to a certain point where the photosite on the chip can't handle any more photons, and it has an absolute limit, and that limit for us would be 65,535 in terms of ADUs. It's not a photons measurement, it's an ADU measurement, a different measurement. But in any case, that's the maximum that we can go to. So when you take a raw image, and that's going to be a FITS format image, the pixels are going to vary somewhere in between 0 and 65,535. When you start looking at PixInsight and also Photoshop, they kind of divide the intensity range up into 3 areas that overlap. Shadows at the absolute darkest end of the spectrum and highlights at the brightest end, with midtones in the middle. So you'll see those terms used a bit, and we will use them also, especially when we get into PixInsight, using PixInsight's histogram transformation. When PixInsight takes a FITS image and puts it into its own format, it scales down the intensities from black being 0 to black being 0 and white being 1. So it scales, if we did have a pixel or a couple pixels that were 65,535, PixInsight would say that's 1, black would be 0, and then everything else would be in between 0 and 1. So we end up having fractions between 0 and 1. So a midtone, for example, in PixInsight might be something like 0.5, 0.4, 0.6, somewhere in there. Shadows would be 0 to maybe 0.3, and highlights would be maybe 0.7 up to 1. They overlap quite a bit, but it kind of gives you an idea that even though we're scaling from 0 to 1 now, we still have the same idea of having shadows, midtones, and highlights. So the one thing that a histogram does not tell you, so it's giving you the intensity for all the pixels in the image. So let's say that there are a bunch of pixels that end up being at 0.5. It will count up the number of pixels that are at 0.5 and show that in the graph. So what it doesn't show you is it doesn't show you the intensity of a pixel at a specific location. A histogram does not do that. It just gives you the number of pixels for each intensity that is present in the image. So to get a closer look at how this works, we're going to run over in Photoshop. I'm going to look at histograms in Photoshop first before we hop over to PixInsight and look at histograms in PixInsight and use the histogram transformation tool in PixInsight. This is a wonderful, colorful picture of my wonderful dog Bix out for a walk, looking at a squirrel, I think. And we're going to look at a histogram for a whole bunch of different types of images. So the way we get to histograms in Adobe Photoshop is under Window, we can go down and find the histogram window, and there we have it open. This is a small view. I'm going to go ahead and open this up a little bit. So this is what Photoshop calls the compact view, the expanded view, sorry. A little bit bigger window that we can see, and also gives you some information here. One of the things that we can look at is this is shot with an iPhone, and a little under 2 million, actually, sorry, about 172,000 pixels in this image. And the histogram, again, is a measurement, a graph of intensity versus the number of pixels that are at that intensity. So intensity is going to be measured from 0 over here to whatever the maximum value is for an iPhone. And so the darker pixels are going to be, the number of darker pixels are going to be represented on the left, the midtones in the center, and then the highlights over here on the right-hand side of the graph. So I want to, this is giving us some color information. I want to move over to change this photo to just a black and white photo, and we're going to see a similar histogram, but just we don't have to worry about the color data here. So again, we have the number of pixels that are represented with absolute black is way over to the left and absolute white way over to the right. And you can see that most of the pixels in this image are somewhere in the middle, with kind of a maximum number of them kind of being here, kind of close in straddling the shadow and the midtone range. And if we look at the picture, it kind of does give us that sense. We don't have a lot of really bright white glaring areas in this photo. We have some dark areas. Bix's snout, the pavement is a little bit black. There's some dark shadowy areas with all the trees and the bushes around, and even the sky isn't super white. So we wouldn't expect to see a lot of highlights over here where the pixels are really bright. But also we can see pretty much everything. So there's an area in here on the left at kind of in the shadow end where it would be absolute black. We don't see a whole lot there. So this is what this is a histogram for what this image is, and again, mostly kind of straddling between the shadows and the midtones. If we compare that to a raw astronomical image from our SPARQ camera at the SPARQ Observatory, this is raw, And you can see there's almost no information here. It's almost completely black. So we have a few little white spots, and the histogram is showing that all the information, all the data in this image is way over here on the left on the shadow side, on the black side. So most of the pixels are closer to the number 0 than to 65,000 over here on the right, which is where the white pixels would be. We have almost no highlights. We have almost no midtones. All the data is over here in the shadow area. So one of our challenges that we have for astrophotography is to take this very narrow band of data that we do have over here in the shadow end, on the black end, and stretch that out as much as we can to create some contrast. And so if I look at this same image but stacked, meaning, so this is a raw Lumen image, and I think we had like 30, 40, 50 Lumen images that we stacked together. And so this would be a stacked image, and you can see that we have successfully moved the data over more closer to the midtones. It's never going to be a picture like this one because we have a lot of background sky, and so that's always going to be black. So we're always going to be kind of on this end. But the reason we don't see a lot of black in here is because we've got a lot of background sky noise. So there's light in the background sky, and so the contrast between the background sky and the galaxy and the stars still isn't that great. So we have even though it's not as narrow, this is a pretty narrow column here on the black end, on the shadow end of the histogram. Even though we have more information here that we can see, it's still a rather narrow kind of area straddling the shadows and the midtones here. And again, almost nothing over here on the highlights. Most of your astrophotography images are going to not have hardly anything over here. You might have a saturated star or something, meaning a star that's for our 16-bit camera, that's at 65,000 something. And that would show up over here, but we don't have a whole lot of those. We have a little bit. Here's a star, and here's a star that are pretty bright, and I can tell they're bright because we've got these we've got some blooming artifacts here that are happening, and so we do have some data in here, and we'll try and bring that out as much as we can. But most of the data, especially for the galaxy, is going to be in this column here. So these are all black and white. Pix in black and white, just a single raw image and a raw and the stacked image. It says unstretched and stretched, but this is actually stacked, not stretched, so just ignore that title there. If we go back and look at the color image of Pix, we can get a bunch of color information here. So in Photoshop, you have a bunch of ways of looking at the data. So this is showing us just the RGB put together, but we can also select just the luminosity. And so that's essentially what we would have here. It's very similar to that. And we can also select each channel. So a channel would be a single color. If we want to select just the red, this is showing us the histogram for the red. What pixels, what are the intensity, number of pixels that have certain intensities of red. And you can see over here we've got a bit of a spike here at the far end. And that's probably in here where these, looks like a maple tree or something. I'm not sure what kind of tree that is, but where some of these red leaves are kind of bright. And if we look at blue, again, we've got a little spike here at the end. That's probably Bix's collar here. And green. A lot of this, we've got some green foliage here, so that might be where a lot of this information is coming from. We can also look at just the colors themselves. And what Photoshop does is it will overlap the different colors together. So where where red and blue are intersecting, we get a little bit of where green and blue are intersecting, we get some yellow. We got some purple over here, and then just a lot of gray area in here, which is where all the colors are kind of meeting together. And again, we can just look at just the RGB information. And so this is just going to be all the RGB together, kind of looked at in terms of luminosity, but it's not actually measuring luminosity, it's measuring the color intensity. So if we go back to our stacked image of NGC 3625, and this is just the Lumen stacked, and compare it to what a final image of this galaxy might be with color, we'll see that a lot of the information has run over to the left side of the histogram, meaning more in the shadow. So here we've kind of, it's in the middle here because we've got all this background noise, sky background noise, but if we go to the final image, part of our processing steps that we're going to be taking are going to be to get rid of that background noise. So we have a lot of black background sky, so most of the pixels, most of this image is black background sky, which is why most of the pixels in the histogram are going to be over on this left side in the shadow. But we do have some other information for the galaxy and for the stars where there's light that we can see. Again, this is just an RGB histogram, and in Photoshop we can look at just luminosity. That's going to change the histogram somewhat. We can look at just the red channel, the green channel, the blue channel, and of course we can just look at just all the colors. And again, this is very similar to the image of Bix in color, where the colors are overlapping a bit. Obviously we don't have as much information. That's a histogram for a photo taken of a dog during daytime on the Earth, as opposed to something that's out into space, really far away with a lot of black background sky. So that's why we see such a difference in the histogram. Our job is to kind of, again, to spread this thin line of data out that we have with a single raw image by stacking the images and then stretching. And stretching we're going to do with the PixInsight tool called histogram transformation. So that gives you a bit of a look into the histogram for Photoshop. One thing I did forget to mention, I'm going to go back to Bix's photo here. We can actually look at an all channels view. So you click on these three lines up here in the histogram and look at all channels, and it will divide up the histogram into RGB. So red here at the top, green, blue. So you can see all three of those along with the total histogram in one shot. Okay, and if we look at our NGC 3628 Hamburger Galaxy, we can see the histograms for the RGB separately here. All right, let's. The cool thing about a histogram is when we're in PixInsight, we can actually change these values in the histogram to change what the image looks like. So right now, the histogram is a result of the image. What we're going to do in PixInsight is we're going to make the image the result of the histogram that we make. And so that's a pretty cool thing. That's called histogram transformation. And we're going to tackle that right now over in PixInsight. We're in PixInsight and we have our Lumen master image open that we've been processing. And we want to use the PixInsight histogram transformation tool to bring out some contrast in this image. And yes, we can see the galaxy and we can see the stars and we can see some smaller galaxies a little bit. And we also have all this cloudiness in the sky background. We're going to deal with that as well in this process. Now you may think, well, we can see plenty of stuff. Well, you can, but you're not actually seeing what the data is actually showing, because the reason we can see anything at all is because PixInsight, we have the auto stretch function on, and we know that because the identifier tab over here is underlined in green. I'm going to go ahead and enlarge this image. And then I'm going to get rid of the auto stretch that's on there, and we'll see the actual data that's there. So you can see, might be nice to actually have some contrast in this image. So this is the actual data. This is a stacked image of dozens and dozens and dozens of Lumen images. and we want to bring out the galaxy and also keep the background sky down. And we're going to use, under Process, PixInsight's histogram transformation tool. And here it is. And so we just looked at histograms in PixInsight, in Photoshop, and now we're going to look at them in PixInsight. It's a very similar thing. First thing we're going to do is we need to realize that we're going to do this in steps. We're going to do this in a bunch of manual iterations. So we're going to stretch the image a little bit, then we're going to look at it, and we're going to stretch it again, and we're going to continue to just do small increments with stretching until we get it to a point that we're happy with before we save the image. So at this point, everything has been what we call linear processing. We actually haven't distorted the contrast in the image. Now we're going to be doing nonlinear processing with our Lumen. And the great thing about PixInsight is it allows you to see the results of what you're doing and mess around with the results of your editing on this before you actually apply it to the image. And the way that we do that is with a preview window, and we're going to go to that in just a second. In the histogram transformation tool, we're going to go down and we're going to reset the tool. And then we're going to click this checkbox, and this checkbox allows us to see the data. And again, here's our histogram here on the bottom, and you can, it's a little bit different than Photoshop, but you can see that there's no data over here in the light area, in the highlights area, a very little bit in down here in the midtones, and then all the data, you can see this spike coming up here on the left. All this is where all our data is. So we need to see if we can not only move all this dark material over here closer to the midtones, but also widen that so we can see more contrast. So we've done the reset. We've got the tracking view on, which is what this is, and we can also see the histogram up here. And then we're going to open a preview window, and that's this blue circle down here at the bottom. And when we open a real-time preview, it allows us to move the histogram in a way that we can start to see some changes and adjust the histogram before we apply it to the actual image. So we're going to actually work with a preview image first. And so here's the preview window that is now open. And you can see that the blue circle is now filled in with yellow-orange, and so that tells us that this is what we're working with. So when we're doing the histogram transformation in PixInsight, we've got three sliders to work with. Over on the right, we have highlights, the middle slider is midtones, and the slider on the left is shadow. At the very beginning, we're not going to deal with shadow at all, and most of the time, it's very rare that you would ever need to move the highlights, because moving the highlights to the left is actually going to dim the highlights. And so we don't have highlights to start with, so we don't want to deal with that. Most of the time, we're going to be dealing with the midtone slider here, and then as we get further into transforming our image, eventually we'll start to work a little bit with the shadow slider, but 90% of this is going to be with the midtones. So if I take the midtone slider, and one other thing I do want to mention is we want to make sure that we have RGBK here and not these other selections. Make sure that you have RGBK, even though we're working with a Lumen image, but that's, you can think of that as K. So we're going to now slide the midtone over, and you can see that the graph is changing somewhat. And if you look at the image, you'll also start to see a few more stars to pop out. So we want to go maybe to about there. You can see a few more stars, and I'm barely, I don't know if you can see this on your screen, just a little hint of the core of the galaxy there. All right, that's about where we want to start. We're going to close the real-time preview image, and we're going to now apply, you notice that the midtone slider is still in the same place. We're going to apply the transformation that we just did to our actual image, and we do that by grabbing the blue triangle down here where it says New Instance and just dragging and dropping it over our image. and you can see that it changed. We could always undo this by going up under Image, Undo Histogram Transformation, and we can see the difference. That's without the histogram transformation we just did, and this is with it. Okay, so all right, we've got a start here. Now we're going to repeat this several times. So the first thing we need to do is tracking view will stay on, but we do need to reset the tool, and you'll notice when we reset the tool that the graph line here going from lower left to upper right will flatten out again and be a straight line, and the midtone slider will return to the middle. So we're going to reset. We're going to open our real-time preview window again, and now we're going to have this newer image where we can see a few more stars, and we're going to repeat the process. We're going to take our midtone slider and we're going to slide it over here a bit. We can see a little more galaxy. Just for fun, I'm going to show you what it looks like. If you happen to want to slide the highlights, please don't do this. This is going to make everything not where we want, and it's also bringing up a lot of background sky. So just leave that alone. So we're just working with the midtones. We can bring this over a little bit. We can see a little more. We're going to close the real-time preview, and we're going to apply this transformation to our image. You can see that we're getting there. We're going to go back to our tool. We're going to reset the tool, open the preview window, repeat, bring it out a bit more. Close this, apply. And one thing that we can now see is we're starting to move the data that we have over off from the far left, from where it's just absolute shadow and blackness, into slowly moving it over closer to the midtones. So this does have a lot of black background sky, so we're never going to get it way over into the midtones, but we're going to at least move it off the left-hand side here. So once again, we're going to reset the tool, open the preview window, and we do have a little room to move the background, the shadow slider, but I'm going to wait for that. I'm going to pull this back over again a bit more, and you can see that it's starting to bring up a bit more. We don't want to go into this area here where there's really starts to be some data that's kind of just not background sky. Close the preview window, apply, boom, it's getting better. We're going to reset the tool, and now we do want to see if we can squish down the background a little bit, and so we're going to grab the shadows slider over here on the left and bring it closer to where our data is, and you'll see that we need to open the preview window. Sorry about that. And now we're going to slide this over, and you'll see that the background sky is going to start to get dark as we go in there. We don't want to get it too close yet because we don't want to start getting into the curve here. If we get into that, that's called clipping the data. We don't want to clip the data. So we're kind of right about where that curve starts to go up. We'll go ahead and move the midtone slider over a little bit too, and we can start to see some more light in the overall image, but again, we're getting a little more sky background, and we'll deal with that in a minute. We're going to close the preview window, reapply, bump. And so this is a reiterative process. We're going to reset. We're going to bring this over. I think I want to get it to just about, we've got some data like starting right here that I don't think is background sky. It's probably dim stars and some dim parts of the galaxy. So I'm going to bring the slider right to there. I'm going to bring this shadow slider over just a little bit, squash down a little bit more of the background, just to where the curve starts coming up. And I forgot to open the real-time preview again. So again, we are going to squish down the background a bit more. There we go. And I think that's starting to look pretty good. We're going to drop that in there, change our image again. I still got a little more sky background than I would like. So I'm going to reset, open up the preview, and I am going to go a little bit with the shadows into into the curve here and see if we can get that just a little bit darker. If you go too far, you can see what can start to happen. You can actually start to lose quite a bit. So we don't want to go too far. And if you look at the graph on the top, it's really starting to look pretty ugly. So we want to kind of keep that nice shape to the curve there. So we're just going to go a bit in there. And I don't think I'll move this just a tad. That's getting okay. I can see a nice little galaxy down there. There's a bunch of little small galaxies in this image that are rather nice. We're going to go ahead and close the preview window again and apply. And I think that's going to be our last transformation. We still have some background. It's not too bad, and we can, if we decide that we want to make it, get rid of that, we can do that also in Photoshop, which we'll eventually get to. But for now, I think this is pretty good. And so this has actually been an actual stretch, an actual using of the histogram to change the photo. And so that's what we've done with this process using PixInsight's histogram transformation. And we know that we have actually changed the data in the image. So this is now a nonlinear image. We have stretched the data and the contrast. And PixInsight is also telling us that because we do not have the green auto stretch under the ID. So when you don't have the green underline under the ID tab over here on the left, PixInsight is telling you, hey Steve, hey SPARQ students, this is the actual data that we're working with right now. And so this is looking pretty nice. We can see the galaxy really nicely. The stars look nice and sharp. Again, this is due to Russell Croman's Blur Exterminator and Noise Exterminator, really great tools that we just used a couple steps ago in our Lumen processing. So the last thing we want to do now is we're going to save this image, and this is going to be the next step in our Lumen processing. So we're going to change 3 to 4, and we're going to change NXT to HT. And this will be the last step that we do for our Lumen image. And we'll click OK. And that's how we use histogram transformation in PixInsight to stretch the data that we have. So we squish down the background sky and bring out the objects that we want to look at. Okay, thanks very much for joining me for this little journey into the wonders and mysteries of histograms. Hopefully that went pretty well and everyone has a good understanding of that. And we'll see you next time, which is when we're going to start processing our color images. That'll be exciting. See you next time. Again, thanks for watching. This is Steve Smith at the SPARQ Observatory.